All right, let's pick back up with problem 7 since I was so rudely interrupted by some kind of spam. All right, so we want to move the 3x over to the right-hand side of the equal. That's going to give me negative 6y equals negative 3x. Remember, it changes sign when you have to go across the equal. So that positive 3x becomes a negative 3x. And then plus 12. 12 was always on the right, so it just stays positive. We're not finished. We've got to divide everything by negative 6. So the negative 6's on the y cancel out to leave just y. Negative 3 over negative 6 simplifies into a positive 1/2 x. And then 12 over negative 6 simplifies into negative 2. So we write that down as a minus 2. Kind of messed that up a little bit. There we go. All right, number 8. Negative 6x needs to go to this side. That leaves me with 2y equals 6x, positive 6x, because it went to the other side of the equal, plus 18. Divide everything by 2 so that we can get y by itself. So y equals 3x plus 9. Problem number 9, we need to move this 8 to the end of the equation on the right side, so it's going to say negative y equals x minus 8, because that was a positive 8, so when it comes over here it's a negative. But we have a negative y, so that's the same as a negative 1y, so we divide everything by negative 1. Some of you know the trick is just change all the signs all the way across. So a positive divided by negative becomes a negative x. Negative divided by negative is a positive 8. And so there's that answer. All right. Problem number 10 says, tell if the given point is a solution to the systems of equations, show work. So this is a substitution problem. So this 3 right here is the x, so it's going to replace that. And then this 3 right here will replace this y value. So it's going to say 3 equals 2 times x, which we know x is a 3, minus 3. So 2 times 3 is 6. 6 minus 3 is 3. So it does actually say 3 equals 3. So yes, it works in this problem. So now we try the other one. 2 times x, which is a 3, minus 3 times y, which is a 3, equals 1. 6 minus 9 equals 1. Well, 6 minus 9 is negative 3 equals 1. That does not work. That's a no. That means the whole problem is a no. That is not a solution. Number 11. The y value is a 7. The x value is a negative 2. So we have 7 equals negative 4 times negative 2 minus 1. Negative 4 times negative 2 is 8 minus 1. 7 equals 7. So it works in the first one. You got to try the second one. So we have 2 times x, so 2 times negative 2 minus y, so minus 7 equals negative 11. So we have negative 4 minus 7 equals negative 11. Negative 4 minus 7 is negative 11, and they are equal to each other. That's a yes. The whole thing is a yes. Okay. Go to problem 12. So we have negative 3, which is going to replace that y value, and then 5 times 0 minus 3. We know that that just kind of cancels out and makes 0. Negative 3 does equal negative 3, so it works in the first one. Got to try the second one. So 3 times 0 plus 2 times negative 3 equals 6. 3 times 0 cancels out. 2 times negative 3 is negative 6. Negative 6 does not equal positive 6. That's a no. All right. Remember, we're going here and here. So we have 1 equals negative 2 times negative 1 minus 1. Negative 2 times negative 1 is 2, minus 1 more. 1 equals 1. That is true. For this problem right here, we have 5 times x. X is negative 1. Minus 6 times y, which is 1, equals 1. Negative 5 minus 6 equals 1. Negative 5 minus 6 is negative 11. That does not equal 1. That is a no. Okay? All right, tell everything you know about the graphs. So the first thing I noticed about the first graph is they're parallel lines. They have the same slope. And they are a no solution problem. Alright. We got E on slope. So there's three things that I see about those. Alright, the next system of equations that are graphed here, I see that they're intersecting lines. Alright, it's a one solution problem. And the solution is, let me stand back and see it, 1 and 1. So I will list that right here. That's enough for that. All right, 16, how many solutions does it have? Well, if I reorder this equation right here, it's going to say negative 2y equals negative 6x minus 8, because this goes this way. These two items both go to this side, so all the signs change. But then I have to divide by negative 2. We find that y equals 3x plus 4. Well, when we compare these two things together, we notice that those are the exact same equation, which means if they're graphed, they're the same line. So this is infinite solution. So take a look at 17. We need to move this over here. So we have 2y equals negative 1x plus 8. Divide by 2. Divide by 2. Y equals negative 1/2 x plus 4. If we take a look at the slopes between these two numbers, the slopes are obviously different. That means if they're different, if the slopes are different in any way, no matter how small, eventually those two lines will cross each other. So that's a one solution problem. And I did have list the solution up here. In class, I told you didn't have to on this particular problem. It is pretty complicated. It was time consuming, it had fractions in it, and so I thought it was better left to spend that time going through the rest of the test. So I told you could stop there. If you were able to solve it, great. All right, problem number 18. So solve the systems of equations. You can solve them whichever method works best, elimination or substitution. Now 18 sets up perfectly to be an elimination problem, as well as problem 19, and we'll talk about that. So when you do elimination, you make sure your x's, your y's, and then your intercepts are lined up top and bottom to each other, and you're looking to cancel or eliminate either the x's or the y's. If you notice on problem 18, you have a negative 3x and a positive 3x. Well, when you add negative 3 plus 3, it makes 0. So the x's cancel each other out. They eliminate each other. 4y plus 1y equals 5y. And then negative 2 plus 7 equals 5. All right. So one more step is divide both sides by 5. Y equals 1. Now we're only halfway there. We've got to plug that back in to find x. So we have 3x plus y, but we know y is now a 1, equals 7. Minus 1, minus 1, 3x equals 6, divide by 3. x equals 2. And our final answer is, it's a one solution, and the ordered pair is 2, 1. And you can write one solution. It is the proper thing to do. That is the final answer right there. One solution, and you include the solution to it. Problem 19, the x's don't cancel. They actually make 3x, but a positive y and a negative y do cancel. 8 plus 1 more makes 9. We're going to divide both sides by 3. X equals 3. And we're going to take that information and plug it back in. I'm going to use the first equation, so that's 3 plus y equals 8, minus 3, y equals 5. And then our final answer is one solution, 3, 5, and we have that answer. All right, problem 20 and 21. All right, problem 20 as well as 21. They're not set up as well to use elimination. You could multiply this entire equation by 8, and that would well, negative 8. Sorry, you multiply by negative 8, and it would allow you to cancel the x's. But it's probably best if you just use the substitution method. So since y is equal to this amount, I can actually substitute that in for y. And so that'll say 4x plus 8 is equal to half x plus 1. So I can subtract half an x on both sides. And I get 3.5 x or 3.5x, whichever you prefer. I can go ahead and do minus 8, 3.5x equals negative 7. So at this point, I would want to divide both sides by 3.5 or 3.5 if you used that. These cancel out, leaving behind x. Negative 7 divided by 3.5 equals negative 2, because 3.5 will go into negative 7 twice. Once we have the negative 2, we substitute that back in. So y equals 4 times negative 2 plus 8. Negative 8 plus 8 makes 0. So this is a one solution problem. And the solution is negative 2, 0. That is the final answer to that problem. We have y equals on this, so that'll be a good place to start our substitution. So we'll have negative 6x plus 2. Now this is 2 times y, so now it's 2 times that whole term that's replacing y, that whole expression. So we've got to distribute right here, negative 6x and then 2 times 3x is going to be plus or positive 6x. 2 times 2 is plus 4 equals 4. Well, right here I have like terms. And normally we would just go ahead and do what it says. We would combine them. But in this case, they actually completely cancel each other out. They make 0. Well, there's no reason for me to really write that. However, I'll show you that. It makes 0 plus 4 equals 4. And if you combine these two things, that just says 4 equals 4. Well, when you get a true statement and all your variables have gone away, well, a true statement means that you have an infinite solution. If you were to graph both of those equations, you would find out that they are the same line. In fact, to illustrate this, I can back up a step and I can actually solve this for y. If I put this piece over here, it would say 2y equals 6x plus 4, and I would divide by 2. Y equals 3x plus 2. And so if you compare this equation and the equation we were given at the top, you'll notice that they are identical to each other. Once again, just proving that it's infinite solutions. They're the same. right, problem 22. Make a table to solve this system's equation, at which point would they intersect. So you need to use this table and you just substitute in the x values right here. So it's -3 times whatever they gave you plus 1. So for the first one they gave me a 0, so that's 0 plus 1, which is 1. For the second value, -3 times 1 would be -3 plus 1, so -2. Right here we would have -3 times 2 plus 1, so that's -6 plus 1, -5. Right here, -3 times 3 plus 1, so -9 plus 1. All right, next problem. 2 times 0 minus 4, so 0 minus 4 is -4. 2 times 1 minus 4, so that's 2 minus 4, -2. 2 times 2 minus 4, 4 minus 4 is 0. And 2 times 3 minus 4, so that's 12 minus 4, which is 8. If you'll notice, you're looking for where do they intersect, where do they have a matching point? Well, right here, that is a matching point, so they would intersect each other at 1, -2. All right, number 23, word problem. A jar contains only dimes and quarters. All right, dimes and quarters. There's my variables I'm gonna use, D and Q, and they add up to 20 coins in the jar. All right, so that means that my dimes plus my quarters equal 20 coins. And then if you continue to read, it says that they actually equal $2.60 as well. So that's a monetary value. Well, dimes and quarters also have a monetary value. A dime is 10 cents, so that is going to be 0.1, or you could use 0.10 if you feel more comfortable. 10 cents times every dime that's in there, plus 0.25 for every quarter that's in there. So that's the two equations that produce the system. Well, just like if this was x plus y equals 20, you would know that you're going to move that x over here. Well, we do the same thing, even though it's a d. So once we move that, that says q is equal to the negative d plus 20. Well, that allows us to take this whole term and substitute it into the second equation for letter q. So 0.10d plus 0.25, but then parentheses come in right here because it's being multiplied times that whole term. Negative d plus 20, close parentheses, equals 260. So I've got to distribute right here. All right, 0.25. All right, so I'm going to go ahead and erase that plus symbol because positive times a negative is a negative, and in this case in algebra it's a minus 0.25d. And then 0.25 times 20 is plus 5 equals 2.60. Right here I need to combine these like terms. 0.10d minus 0.25d is negative 0.15d plus 5 equals 260. So I subtract 5 from both sides. So negative 0.15d is equal to, let me check that with calculator, we'll mess up right here. All right, 2.6 minus 5, all right, negative 2.40. Divide both sides by negative 0.15 so that we get right here, so that we get d equals, we'll divide that on my calculator, 16. So that's half of our answer. So we know there are 16 dimes. And obviously, if there's 20 coins in there, there's got to be 4 quarters. But let's check. If we plug that back into one of our equations, we could do 16 plus q equals 20, minus 16, minus 16, q equals 4. So absolutely there are 4 quarters. That's the other part of the equation. 16 dimes, 4 quarters. All right, problem number 24. Inside the stables, there are horses and people. All right, horses and people. I'm going to use H and P. So H plus P equals 9 living people plus horses. 9 living beings, I guess. All right. Also, that someone counted the legs of all of the people and horses, and together it made 30. So we've got 30 legs on all the beings in there. And so you got to think a little bit about horses. Horses should have 4 legs. 4 legs per every horse. 4 times every horse is 4H. Plus people should have 2. 2 legs times each person. So there's our system of equations. Once again, we'll take this H and we'll move it over here to this side. And that'll give us P equals negative H plus 9. And then we're able to substitute that in for letter P of the second equation. 4H plus 2 times negative H plus 9 equals 30. So we distribute here 4H plus, actually we're going to have 2 times a negative, so I'm going to back that up a little bit. It would be plus a negative, but I would rather just write it as minus 2H. All right, plus 18 equals 30. We combine these like terms right here to get 2H plus 18 equals 30, minus 18 from both sides. We get 2H, sorry about that, 2H equals 12. Divided by 2, divided by 2, H equals 6. So we now know that there are 6 horses. And then if we use that to plug back into one of our equations, we can do 6 plus P equals 9 minus 6 minus 6. P equals 3. So 3 people. All right, that's problem 24. Problem 25, multiple choice. You're just going to pick the correct system. Stacy charges 2 per day. That's a keyword for slope. And a sign-up fee of $3. That's a one-time fee. So this is y equals 2x, 2 per day, and then a one-time fee. So we're looking for one that has that. So I see it here, here. So we got to keep going because there's two choices. Sorry, 2 choices. This is not ordered correctly. 2 choices. So we look at the second equation. Zach charges a flat rate of 3 per day. So Zach is going to be y equals 3x with no sign-up fee, no flat fee. So nothing on the end of his. So that is going to be choice C. So one that matches. All right. Last problem on the back. 26. 200 playoff tickets were sold last week. Some students bought a discount rate ticket, so a discount ticket of 10, while others had to wait too long and had to pay 15 for a regular price ticket. Okay, so I had 200 tickets were sold, and you had discount plus regular. Discount tickets plus regular tickets made 200. All right. Also, I've got a monetary value. So here's $2,450. Well, discount tickets were $10 a piece, so $10 times every discount ticket, 10D, plus 15 for every regular price ticket, so that's 15R. Once again, I need to move something around to get this to either say D equals or R equals. So in this case, I could just move the R to this side if I wanted to. And at that point, it would say 200 minus R equals D. Well, since I know the value of D, I can plug that in right here. I can substitute it for D. So it would then say 2450 equals 10 times 200 minus R plus 15R. And I won't take that any further because it says that you didn't have to. All you had to do was find the two equations. But this is how it would be solved. Whoops, went a little too far with that one. And from there, you could go ahead and solve it.